In my last video, I wired up the LM334 adjustable current source to provide 0.1 milliamps of current, or 100 microamps, however you want to look at it. I have here a 100 microfarad capacitor that can be charged up to 50 volts. And so this demonstration is going to show that a 100 microfarad capacitor that is getting 100 microamps of current will take 1 second to charge each volt. So this works with all capacitors and current. So a 1 farad capacitor being charged at 1 amp of current will rise 1 volt every second. And so it's scalable. We're going to deal with micro in this case, 100 microamps, 100 microfarad. So I have the V plus pin, the top pin, connected directly to the positive rail, the R pin, the middle pin, and the V minus pin, the bottom pin. They have the resistance set to provide about 100 milliamps of current through the component. And so on the other end, we're going to put the capacitor. It's polarized. We're going to put the negative side, so you can see negative there, pointing down to that lead, which is also shorter. If you haven't trimmed them, we're going to put that short lead to the negative rail to make sure that stays negative. So now, we are going to, let's zoom back for a little bit, measure the voltage with the multimeter here. So, black probe. I have alligator clips crimped to these wires, and so I will plug them into there. So we'll look at this, zoom back so we have a better view, plug that to the negative rail, and the red one, we're going to go up here where the capacitor meets our adjustable current source, right there. So hopefully that's pretty easy to see, and we didn't have to go back that far. But now we're going to turn the meter on, and the capacitor doesn't really discharge all the way. It's an electrolytic one. If you discharge it all the way and then remove a load or a power source or something, it kind of drifts back up a little bit towards the voltage it was before. And so we're going to take this jumper here and just short circuit the capacitor. It doesn't have hardly any charge across it right now, and so this is no big deal, but if it had a higher voltage charge, we might see a big spark when we do this. But in any case, there we are. We short circuited it. Now you can see that it is holding 0 volts. So I'm going to turn on the bench power supply, and so now current is flowing through the current source that we set up before, but it's going through this wire, so there's no voltage buildup across the capacitor. I'm going to yank the wire, and what we're going to notice is that it's not 100, or it's not a perfect 100 microamps, and of course it's not going to be a perfect 100 microfarad capacitor, but they're both really close. And so every second we should see about 1 volt rising on the display here, and it's a steady voltage. So that's the main thing. It's a steady rise. It kind of flickered because it's auto ranging. It just went into a different range. But there you can see 18 volt power supply. It's steadily going. It's not going to hit 18 volts because of losses and stuff. But there you can see, boom, we just came to a stop. But it was a steady rise. So if you're looking at a chart, you'll just see a straight line going until you get to a maximum voltage point. Then it will cut off if you let it get that far. Otherwise, you have a steady rise. So you can make a ramp and use techniques like this to make a triangle wave generator or something. The main takeaway though is that if you charge a capacitor at a steady current, which a current source provides, and this is a simple one I covered in recent videos, it's really easy to get a steady change in voltages with a capacitor. So hopefully that all made sense, and hope to come up with better demonstrations in the future. And so if you want to support this channel, make it easier to do that. Of course, like the video, watch the videos, and if I link products and you live in the United States and you buy anything from after clicking those links, that helps. Also, I have a Patreon that I put in the video description, so that would help the most. But in any case, any support is great. So thanks for watching. I'll see you in the next video.